So we're in section 3.8 now, and we're going to talk about unions and intersections of sets. So we've kind of talked about this a little bit already, but remember, unions, think set A and set B. The union of those two is indicated by that symbol, it's like a U. And then intersection is over here, and that is set A and set B. Their intersection is indicated by that upside down U, or like it looks like an N. Think intersection, okay? So those symbols are important. And the vocabulary here is obviously union, intersection, and then disjoint sets, which disjoint sets are sets that have no elements in common. But we're going to talk about that in just a minute. So the title at the top of your notes now should be this. All right? And then these vocabulary words should be written at some point throughout this with their definitions. So let's look at this Venn diagram. We have the universal set, which is indicated here by the U. And within that universal set, we have set A and set B. So, if we want to talk about the union of set A and B, we would shade everything in set A and everything in set B. So the union is all of A and all of B. However, if we wanted to talk about the intersection of A and B, it would be all of this that is shaded both yellow and red. It's the overlap. So, going back to thinking about inequalities that have and or, inequalities with or, saying it could be this or it could be that, would fall in here with the union. Because it could be something in A over here, or it could be something in B over here, or it could be somewhere in the middle. For the intersection here, which is this middle part, the word is and. So the inequalities, the compound inequalities with and, would fall under intersection because it has to be A and it has to be B. And the only part that it's both of those, A and B, is in this overlapping part in the middle. So the union of two or more sets is the set that contains all elements of the sets. So one of everything from both sets. The intersection of two or more sets is the set of elements that are common to every set. So it has the set of elements that is in both set A and set B. Together that makes up the intersection. But there's this one other kind of set, the vocabulary word from the beginning, which was disjoint sets. We're going to look at that on a... So disjoint sets have no elements in common. So it's disjoint sets. Okay? They have no elements in common. So if we had a Venn diagram, this is the universal set, so it includes everything inside the box. This is A, this is B. Well, here, this is what we've seen so far, right? And we have an intersection point right here. But if they were disjoint sets, it would look a little bit different. This eraser's not working as well as I thought it would. Okay, so if they're disjoint, we have A over here, and we have B over here. So they're not sharing any common elements. They're both still a part of the universal set U, right? Because they both fall within this box. But right now, they have nothing in common. So what do you think their intersection is? The intersection set. It's the empty set. So A intersection B, in this case, equals the empty set, which is written that way, or a 0 with a slash through it. So the intersection of disjoint sets is the empty set. That's an important point. Let's look at this example. So let A equal 2, 4, 6, 8, B equals 0, 2, 5, 7, 8, and C equal n such that n is an odd whole number. So don't look over these important details. Odd whole number. So set A and set B are in what form? Roster form, right? They're listed out, so they're in roster form. Set E is in set builder notation. Good. So these sets are listed out. They're pretty obvious for us, but in some cases you might have to think a bit more about it. Usually when it's in set builder notation, you'll need to think, okay, well, what exactly is this set before moving forward? And you kind of need to define the elements in the set. But in this case, they're pretty obvious. So let's start with A. What is A intersection B? Right? So these symbols are really important because you don't want to get that confused with union. So what is A intersection B? Well, let's remember, intersection is the set of elements that are in both sets. So what is in A and B? Well, let's look. We have a 2 in both of them, right? So you would write it like this. A intersection B equals 2 is in both of them. 4, no. 6, no. 8, yes. So I just worked my way through set A here. I said 2, yes, there's a 2. 4, no 4. 6, no 6. 8, check. And then do I need to even look at it's set B at this point? No, because the intersection, the elements have to be in both sets. So that takes care of A. B, what is A intersection C? Well, n is an odd whole number. So that means we need to have odd whole numbers in A, and do we? No, we don't. So these are disjoint sets, and their intersection is the empty set, right? Again, because C specifies that n is an odd whole number. So in set A up here, those are whole numbers, but they're not odd, they're even. So there's no intersection, there's no overlap between these two, and their set is the empty set, which again, you can write with these braces with nothing in them, or you can write it with a 0 and a slash through it. Either one of those signifies the empty set. All right, now let's look at C. What is C intersection B? Well, again, n is an odd whole number, that's C. So for B, let's look at it. Well, we can just work our way through B and say, is 0 an odd whole number? No. Is 2 an odd whole number? No, it's even. 5? Yes, 5 is an odd whole number. 7? Yes, 7 is an odd whole number. 8? No. 8 is even. So our intersection, the intersection of set C and set B is 5 and 7. Okay, here are your first 4 practice problems. So, given these 3 sets, find each union or intersection. Okay? So, this is X union Y. This is X intersection Y. This is X intersection with Z. And this is Y union Z. So go ahead and hit pause and you can solve these and then we'll move on. Now let's take a look at this word problem. So, of 500 commuters polled, so that's our total, right? That's kind of like our, you would think our universal set. Some drive to work, some take public transportation, and some do both. So we have 2 options here. So we know we're going to have two circles, right, in our Venn diagram. Let's call this D for drive to work and this P for public transportation. And then their intersection here, that's going to be the ones that do both, right? But grand total is all going to add up to 500. So we have 200 commuters drive to work. And 125 use both types of transportation. So that's our first absolute. 125 use both types of transportation. Well, let's back up. We have 200 that drive to work. So we already have 125, right, in this circle here. So that 200 includes that 125. So how many are just out here in the circle by themselves? Well, 200 minus 125 is 75, right? So we have 75 that just drive, 125 that do both. So that's 200 total that drive. Now how do I figure out how many just use public transportation? Well, remember we had 500 total. So 500 minus 200 equals 300, right? So 75 only drive, 125 do both, 300 only use public transportation. How many use public transportation total? Well, you add 300 and the 125, right? So that would be 425 use public transportation. Okay, here's your fifth and final practice problem. Of 30 students in student government, 20 are honor students and 9 are officers and honor students. So, let's underline our key points. 20 are honor students and 9 are officers and honor students. All of the students are officers, honor students are both. How many are officers but not honor students? So draw your Venn diagram, fill it out, and use it to help you find the answers.